In this video, we're going to work through a couple of conversion practice problems on the worksheet, conversion practice worksheet. The first one I want to look at is on number 2. Given the flow velocity of a river in 125 feet per minute, calculate the flow velocity in yards per hour. This is definitely a conversion type of problem, as we're changing feet per minute into yards per hour. The biggest mistake that I see students making, so don't write this, is writing it as 125 feet per minute. Although it's correct to write it as 125 feet / minute, in a conversion type of problem, we do not want to start out that way because it can cause us issues. So what we're going to do is we're going to write it as 125 feet on the top and minute on the bottom. When we write it like this, it makes it very clear to us what units are on top and what units are on bottom. So now we know that feet are on the top, so when I use a conversion factor, I'm going to put feet on the bottom. Minutes are on the bottom, so when I use the conversion factor, I'll put minutes on the top. So we know that we need to change feet into yards. We also know we need to change minutes into hours. It does not matter which one I change first. I typically start with the top units and change them. So I'm going to go over to my length and see if there's one conversion factor that allows me to go from feet into yards, and there is. 3 feet is equal to 1 yard. So on the bottom, I'm going to put 3 feet equals 1 yard. I want to put this conversion factor in so that it cancels out my units. So I'm going to put the 3 feet on the bottom, and I'm going to put the 1 yard here. Obviously, feet is abbreviated FT here and then not here, but they're the same. So I cross those units out. If I were to take 125, divide it by 3, I can ignore the 1 because multiplying by 1 doesn't change anything. 125 divided by 3, I'd get my answer, and it would be in yards per minute because yards are on the top, minutes on the bottom. But it doesn't ask for yards per minute. It asks for yards per hour. So I'm going to multiply by another conversion factor, and I'm going to write down, I know off the top of my head, the conversion factor between minutes and hours. I know that there are 60 minutes equal to 1 hour. So now I need to figure out how to place this conversion factor in here. Since the minutes are on the bottom, I've got to put the 60 minutes on the top so that the units will cancel out. So now the 60, not the 60, but the minutes crosses out with the minutes. Now the units that I have left are yards on the top, hour on the bottom. That's what I'm looking for, yards per hour. So any numbers that show up on the bottom, I got to divide by them. Any numbers that show up on the top, I got to multiply by them. So when I do that with my calculator, 125 divided by 3 and then multiplied by 60, I end up with 2499 and then all nines. So I'm going to look here. Remember that conversion factors have an infinite number of significant figures, so we don't pay attention to those in conversion factors. So I started with 3 significant figures, so I need to end with 3 significant figures. So if I go 2,500, that only gives me 2 significant figures, and that's yards per hour. I'm going to write it as a slash because it's my final answer. But very important, if I show it like this, I think on the calculator it's 2,499.99, and it just keeps going with the nines. So if I just wrote it like this, these are trailing zeros and they don't count. So it only show 2 significant figures, but I'm supposed to show 3 significant figures. This is when we have to use scientific notation. And we would move the decimal 1, 2, 3, and it would become 2.50 e to the 1, 2, 3, e to the third yards per hour. Now, this is a trailing zero, but it's to the right of a decimal, so now it counts as being significant. So this allows me to show the correct representation of 3 significant figures. I hope this helps in understanding conversion factors that are dealing with units on the top and units on the bottom.